pair of dice is rolled. What is the probability of rolling a sum of 9? I took a liberty of going ahead and drawing out the sample space, and I usually write it as a 6 by 6 square, indicating every possible combination of first and second die rolls. So you can see there are 36 equally likely elements in the sample space, and we want to know the probability of rolling a sum of 9. So the probability that the sum is 9 is just going to be by the basic probability principle. It's going to be the number of ways to get a 9 divided by the total number of ways to get any sum. Now, because there are 36 equally likely elements in the sample space, I know the denominator is 36. But I also know that I need to look for how many sums of 9 do I get. I get a 6, 3, and that's a 4. So I get a 5, 4, that's 9. I get 4, 5, that's 9. I get a 3, 6, that's 9. So when all is said and done, there are exactly 4 of those 36 possibilities that give a sum of 9. Now, of course, you need to reduce that, but once reduced, you have your answer. The probability of rolling a sum of 9 by the basic probability principle is 1/9. Now, we'll need to remember this answer because the second part of the question relies on the first answer. So let's look. The B part says, what are the odds in favor of rolling a sum of 9? Well, first of all, remember, we're going to use the answer in part A in our work. So I'll go ahead and write down that part so we'll have it. So from part A, we know the probability that the sum is 9 is equal to 1/9. That's from part A. You've seen the formal definition of odds in favor of an event. The odds in favor of an event A is simply defined to be the probability of A over the probability of A prime. In other words, write that a little nicer there. Yeah, there we go. The probability that A occurs over the probability that it doesn't occur. That's the definition of odds. If you use that definition, it's easy enough to get the solution. According to that, remember the event A here is that the sum is 9. So that'd be the probability that the sum is 9 over A prime. That'd be the probability that the sum is not 9. Well, of course, both of those are easy. We already know the probability the sum is 9 is 1/9, so that's simple. If the probability the sum is 9 is 1/9, then the probability that the sum is not 9 is 8/9. Now, simplifying that, remember when you divide fractions, you invert the divides or multiply, so that becomes 9 times 9/8. The 9's divide out, so you get 1/8. And remember, sometimes odds are written as a fraction, just like probability, and sometimes they're written with a colon. So either way you look at it, the odds in favor of rolling a sum of 9 is 1/8, using the definition. However, you probably know that I never really use the definition, and I'm going to do it the way that I like to do these problems, and of course you have your choice. But let me remind you just a minute about how I do this. I always think of these problems, the whole sample space is partitioned into two pieces. If you take the sample space, the whole thing, you can break it into the part of the sample space that consists of what you want. For example, with our die roll problem, we would want all the die rolls that give a sum of 9, plus the part you don't want, and that would be the rest of them. So you can always partition the whole sample space into the part of the sample space that you're looking for, the part, what I call the part wanted, and the part you don't want, which is just the rest. If you think of it that way, you can define the odds in favor of an event as being the number of elements in the part that you wanted, in this case a sum of 9, count how many give a sum of 9, over the part that you don't want, the rest of them, in other words. Whereas a probability is always given by the part you want over the whole thing. When you're doing odds, it's the part you want over the part you don't want. So odds are part to part, and probabilities are part to whole, and that's the way I think of it. And again, remember, you can write an odds as a fraction, or sometimes they write it with the colons. Either is equally correct. But the point is, going back to an alternate solution, which I would prefer actually, I would say, well, in this problem, the sample space has 36 elements. That's the total size of the sample space. And you can break it up into what you want versus what you don't want. Remember that there were 4 rows that would give me a sum of 9. 6, 3, 5, 4, 4, 5, and 6 and 3, 6. So there, if I think of it that way, I can break this up into 4, and then the rest of them, which will be 32. This is the part that I want. I want a sum of 9. This is what I don't want, which is just the rest. At first, this sounds maybe like a harder method of doing it, but once you understand what's going on, it's really pretty simple. Whenever you see an odds problem, you can always think of it this way. So if someone told me that the probability that the sum is 9 is 1/9, I would immediately say, well, that means the 9 can be broken into pieces based on what you want versus what you don't want. So I would think of that 9 as 1 plus 8. If you looked at the unreduced fraction, you'd be working with 4 and 36. But it doesn't matter. It's going to come out the same each way. Once you've simplified the probabilities of fraction, you might as well work with the simplified numbers. So the 1 is what you want, and the 8 is what you don't want. Once you write it that way, you can just look and see what the answer is for the odds. So the odds in favor would simply be the part you want, which is 1, over the part you don't want, which is the 8. So when you're looking at it that way, it's just going to be a fraction made out of the 2 pieces of the denominator. That goes here, and that goes here, and that'll work each time. So if you partition the denominator into what you want and what you don't want, the sum of those 2 things, then you can make a fraction out of it. So your answer would be 1/8, or if you want to write it as a expression with a colon between them, and notice it's exactly the same answer you got by definition. Your choice. The C part of that question says, what are the odds against rolling a sum of 9? Now remember that we've already calculated the odds from part B. We've already calculated that the odds in favor of a sum of 9 is simply 1 to 8. That's what we found out in part B. So the odds against a sum of 9 is simply a reversal, 8 to 1. It's just that simple. Once you get the odds in favor of something, the odds against is just a reversal.